Greetings to everyone. So we're going to discuss about heaps as a type of data structure. First thing to learn about this is heaps falls under the family of binary trees. So if you're familiar with using the binary trees, this will be easy for you. So, and for those who are new to this, I'm here to help you out. Definition of heaps. So heap is a special type of binary tree where the value of the root node is compared to its children to arrange the flow of data in an order. It features conditional statements for integers, namely less than or equal and greater than or equal to. Heaps have two main types. So the first one is the min-heap or the minimum heap, and the max-heap. In other words, the maximum heap. So here, yeah, this is what a heap data structure looks like. So this is the min-heap. This one. Yan. So, in inserting a value in a minimum heap, the root or the parent of a node must be less than its child. So, here, the parent is only 10, then the children are 15 and 30 for the child. It's 15 and 30. So, next is, and this one, it is the total opposite of the minimum heap. The root or the parent of a node must be greater than its child. So it's 100. Then the child are 40 and 50. 40, 50 lower than the parent. And then the next one will be, so first thing first is the minimum and maximum. The minimum and maximum. Heap. For min-heap, we can use the minimum method to get its root node. So you remember the minimum method we got from the binary trees. So for min-heap, since we have for min-heap, the root node is the smallest value out of all the nodes. So we can use the minimum method, which will return the smallest value, which is the root node. So for maximum heap, in which the root node is the highest value, has the highest value. So if we use the maximum method, which returns the greatest, the biggest number, which is the root node here in heaps. So next is the ExtractMin and ExtractMin. This method removes the root node for each type of heaps. Upon removing the root node, the smallest of its child, which is the left child, would be the new root node for the min-heap, while the largest of its child would be the new root node for the max-heap. So it is same as the what do you call this? The deleting method in binary trees. But the difference will be if we remove the root node, the smallest of its child, which is the left child, would be the new root node for the min-heap. So insert. We add a new key at the end of the tree if new key is greater than its parent for minimum heap, or if the new key is less than its parent for maximum heap, then we don't need to do anything. Otherwise, we need to traverse up to fix the violated heap property. So it is almost same as this decrease key, but instead here we're going to insert. So if we add a new key, maybe Oh, we can't. So maybe if we're going to add, and if new key is greater than its parent for minimum heap, so this one is greater than its parent. The next method is a delete. And this method removes a node within a heap. After removing the decrease key, method can be used to replace the node deleted. So its difference with the decrease key is we delete inside the node, we delete it of the queue. So here in the queue, we're going to prioritize which one we're going to use. Is it the greatest to least or the least to greatest? We need to before doing a program or the before starting the data structure, we need to have a certain uh, choice if we're going to use at least to greatest or greatest to least. If we didn't think about it beforehand, so we cannot start implementing heaps. Next is the methods of priority queue. So the first one is the poll. And this method removes the queue. So if the queue is 1, 2, 3, 4, and 5, the value that will be removed will be this one, the 1. Yeah, like that. Next is the insert method. So here in insert method, this method adds a value within the queue. So let's say that I have a queue. It has 1, 3, 4, and 5. So here we're going to, since this is what I choose, the from least to greatest. Here also I used the least to greatest. So here, if I'm going to add a value, it will be, I'll add 2, so we can find, since 2 is greater than 1 and 2 is less than 3, 2 is less than 3, then it will be inserted here. Yeah, like that. So that's all for the heaps. For the next topic, we'll be talking about hashing. So as for the definition of hashing, yeah, hashing is an important data structure which is designed to use a special function called a hash function, which is used to map a given value with a particular key for faster access of elements. So the efficiency of mapping depends on the efficiency of the hash function used. So this is what a hashing data structure looks like. Yeah. So here, and let a hash function h of x maps the value x as index x modulo 10 in an array. So for example, if the lists of values 11, 12, 13, 14, and 15, it will be stored at positions 1, 2, 3, 4, and 5. So in the array or hash table respectively. So yeah, that's how the hashing data structure looks like, and that's how it works. So next is the next And so, hashing algorithm. So, a calculation applied to a key to transform it into an address. So, this index number can be used as an index number. So, in case of dealing with strings and characters as key, unlike the first thing, which is the index number, strings and characters can be used as keys. So, if we use strings and characters, we can use the ASCII code to transform it into an address. So as for the numeric keys, divide the key by the number of available addresses n and take the remainder. So this remainder will be used as the index number. So if we're going to use division method, we can get the address by using key modulus n. And for multiplication method, we can say that the address is equals to floor, open parenthesis n, open key a modulus 1, and close parenthesis. Whereas a is any constant value between 0 and 1. So, yan. If your division method is much more simple than the multiplication method. So for alphabetic keys, divide the sum of the ASCII codes in a key by the number of available addresses n and take the remainder. So, yan, it's always the remainder. Folding method divides the key into equal parts, then adds the parts together. Next will be the direct address table. So the direct address table is a data structure which uses array to assign keys for each corresponding element or value. In this table, we can directly assign its key as its index number, and this type is used for fast searching, insertion, and deletion of data. So this direct address table, we have, if in any case, upon getting an element's address, you encounter a duplicate address for different keys, you can apply the so-called collision method. So in this collision method, we can either use chaining or open addressing method. So let's discuss first the chaining method. So here, the chaining method, when you have encounter having duplicate records for each index key, you can implement a linked list in that specific key. Next is the universal hashing. So hashing method that can be applied in most of our hash functions. Next is the open addressing. So as for the open addressing, next is the open addressing. Open addressing, yeah, in this method, records are stored in the table itself. In this scenario, the table size must be greater than or equal to the number of elements to be inserted within the table itself. So this open addressing can be used in three ways. So first is the linear probing. Looking for a vacant slot within the table by means of linear method, checking if a key has a record one by one. Once a vacant slot is found, the value is inserted in this key. That's the first way. Next is the quadratic probing. For every iteration 1, we check if the sum of hash of x and I2 is none. If it's none, then we will use the I plus 1 multiplied by 2 up to I plus 1 multiplied by n until we get a vacant slot. And the last one is the double hashing. For every iteration I, we check if the sum of hash of x and I multiplied by hash 2 of x is none. If it's none, then we will use the I plus 1 multiplied by hash 2 of x up to I plus 1 multiplied by a hash 2 of x until we get a vacant slot. So that's all about hashing.